Welcome to another Avaya technology session. In this updated series of presentations, we will be providing you with the content that was presented at the 2015 Avaya Technology Forums. The Avaya Technology Forum is the place where the latest technology developments and trends are discussed with Avaya's most experienced and brightest engineers and architects. While the value of the interaction with our experts cannot be replicated here, we are coming as close as we can by bringing you the presentation content. In this session, we will discuss the ease and technical superiority for the support for secure elastic services on Avaya's SDN Fx Fabric Connect. I am Ed Kohler, and I will be your host for the session. This is a comment made by one of history's most ancient military experts. Anyone who has read The Art of War may recall the entry. It was written at a time when what is now modern China was fragmented into a series of independent kingdoms that were almost perpetually in a state of war. This is a comment that one might hear at a modern staff meeting around the importance of security to the enterprise. The message is that the basic tenets of the philosophy of martial interaction do not change. Additionally, the new dimension of cyberspace only extends this age-old paradigm into modern times with frightful implications. As we rush to create an Internet of Things, or dare us say, an Internet of Everything, we need to realize that we are actually expanding and perhaps even upsetting on this ancient balance. One of the deepest and yet most obvious secrets is that security, as in warfare, is a constant arms race. But if one considers things closely, the match is seldom even. Historically, attackers have tended to outpace defenders in terms of innovation. Once this is pointed out, makes perfect sense in that one does not prepare for defenses against weapons that do not yet exist. New weapons need to be developed and, more importantly, used in conflict before new defenses can be created to rise to the new threat. As such, it should be realized that there is only so much a defender can know about an attacker, their weapons, or their methods. Taking this into consideration, prudence would indicate that it is always best to assume that the attackers know more than you think they do. It is also good prudence to assume that their skill and capabilities are more than what you think they are. And finally, as a defender, anytime you can change the rules of the battleground on your opponent, you should do so. Today, we'd like to share with you some insights as to how this might be accomplished. In recent decades, communication technologies have realized significant advancement. These technologies now touch almost every part of our lives, sometimes in ways that we do not even realize. We often refer to this trend or set of trends as the Internet of Things, or more recently, its extension to the Internet of Everything. As this evolution has and continues to occur, many systems that were previously treated as discrete are now networked. Examples of these systems are power grids, metro transit systems, water authorities, and many other public services. Other examples are networks that require regulatory compliance, such as PCI DSS and HIPAA. While this evolution has brought on a very large benefit to both those managing and using the services, there is the rising specter of security concerns and the precedent of documented attacks on these systems. This has brought about a strong concern about this convergence and what it portends for the future. The question begs, though, why is this so difficult, and what's wrong with IP? Well, actually nothing. It works as designed, but recall that security was never a part of the assumption for IP version 4. It is only addressed as a series of RFCs as an afterthought. In the case of IPv6, security plays a much more prominent role in consideration, but still has many issues and holes to the overall security challenge. IPv6 hop-by-hop routing still requires that the IP route be visible in order to operate. This creates a catch-22 in that you can only hide IP routes to a certain degree before you start to break the very reachability that you're trying to protect. Any approaches to address this in traditional fashion usually have high costs associated with them. There is also the white elephant in the room when speaking about the Internet of Everything. It will require a massive increase in IP network addresses. Many will rather naively point to IPv6 as the answer to this issue, but unfortunately, it's not even half of the answer. Yes, it's true that IPv6 offers a huge address space, but also consider that in turn, the IPv6 address itself is huge. It needs to be in order to express the expanded space. Also realize that many of these microsensors will not have the effective resources to deal with such large addresses or table spaces. As a result, we will require concatenation gateways that will allow for very short-form addresses at the sensor level, but represent them at a globally routable level, either discretely or as a community. It is also worth considering that BGP is currently reaching its limits of scale, and the increasing introduction of IPv6 is only hastening the approach of its ceiling with the current infrastructure. Furthermore, just think about the densities of IP transit routes that exist. Now, these are subnets existing purely and solely as a transit for end-user network-to-network traffic. Really, when you think about it, this is a very huge waste of address space. And IPv6, in the traditional sense, really doesn't alleviate this. Consider also that using IP as a path utility protocol exposes the network to certain security concerns, such as IP scanning, to learn the network topology. From there, certain attack vectors can be identified and leveraged, with the eventual result being attack on the infrastructure or a confidential data breach. In short, if we can remove the dependency on IP to establish service paths, everything becomes much easier and much more scalable. At Avaya, we've changed the rules. We have established path behaviors at a different protocol plane. This allows Fabric Connect to establish service paths that are totally transparent to IP scanning techniques. As a result, IP becomes a service within the Fabric Connect network. To put it in the parlance of the Internet of Everything, IP subnets and networks now become entities or points of service within the network. This makes IP as a protocol much more secure because, in this sense, it's truly virtualized and has no attachment to the physical topology. Now that IP is established to a service level, we can use it and advertise it, use it and hide it, or perhaps not even use it at all, as many process control protocols are not IP, but instead based on varieties of L2 protocol constructs known as SCADA, or supervisory control and data acquisition. The end result is an environment that, if properly engineered, will yield no IP topology information. We refer to this as stealth network services topologies. It is important to consider that a true security practice includes not only technology, but people and processes as well. There are several aspects of security that go beyond the more well-known technologies such as firewalls and intrusion protection systems. As an example, there is now the need to record the flow of secure data within the enterprise. There is the expected validation of where confidential data exists and for what purpose, as well as how long it is to be stored. Also to be considered is the proper classification and handling of the respective data. Additionally, any methods of segmentation or security will need to be documented, and penetration testing as well as ongoing threats and analysis review needs to be performed. Of a particular note, the more technologies used in the end-to-end secure domain, the more penetration testing and different methods have to occur specific to the technologies involved. As a result, using Avaya's Fabric Connect based on IEEE 802.1AQ can significantly ease these requirements. This is because Fabric Connect can be used in an end-to-end fashion, from the data center top-of-rack environment to the edge end user. One technology, one protocol. Avaya's SDN Fx Fabric Connect is an enhanced implementation of IEEE 802.1 AQ shortest path bridging. Fabric Connect can offer a series of circuit-based services that can be either layer 2 or layer 3 depending on the user requirements. These circuit constructs are known as ISIDs, or Individual Service Identifiers. If these services are used in the proper fashion, they can yield what are termed as stealth networking services. A stealth network is simply any network that is enclosed and self-contained, with no reachability into and or out of it. It also must be mutable in both the services and coverage characteristics. Avaya's Fabric Connect, based on IEEE 802.1 AQ, provides for fast, nimble private networking circuit-based capabilities that are unparalleled in the industry. They do not require complex mixes of protocols or design practices. Hence, stealth networks are private, dark networks that are provided as services within the Fabric Connect cloud. They come in two different forms: a layer 2 stealth, which is a non-IP L2VSN environment, and a layer 3 stealth, which is a layer 3 VSN IPVPN environment. Let's take a moment and talk about the anatomy of these circuit-based services. The anatomy of a layer 2 stealth network is actually very simple. It is nothing more than an ISID that is associated with VLANs. The VLANs are not given IP addresses, however. As such, a standalone layer 2 network is created where nothing can enter or exit. These are extremely useful to extend secure layer 2 protocol environments such as those required by SCADA. Additionally, IP can run inside of the layer 2 stealth network, but it is a self-contained IP subnet that is not routed to the outside world. It is in essence invisible. As a result, they can be used for secure data center usage where IP reachability is not necessarily desirable. Finally, a comparable service, an MPLS known as LEPLS, requires roughly 30 to 40 command lines of code to execute, whereas a layer 2 stealth network in Fabric Connect is in essence one command line. The anatomy of a layer 3 stealth network is also very simple. It is nothing more than an ISID that is associated with virtual route forwarders, or VRFs. The VLANs attached to the VRFs are given IP addresses. However, none of the IP subnets are reachable outside of the IPVPN environment. As such, a standalone layer 3 IP internet is created, which is dark and where nothing can enter or exit. It is, in essence, invisible to the outside world. This type of service is useful for any secure layer 3 protocol environment, such as PCI DSS or HIPAA networks, but are also useful to provide service separation for possible conflicting protocol environments, such as in the case of multiple multicast domains. These services can be used in tandem and in combination to yield a totally closed network topology. As shown in the slide, using PCI as an example, a layer 3 VSN can be used to extend out the PCI compliant network to the far endpoint of sale applications. These PA-DSS application end systems will gain access to the PCI network via Identity Engine's authentication. The layer 3 VSN is then extended up to the data center security demarcation point, where there is a single secure port that enters into the perimeter of the firewall IDS boundary. On the other side of the demarcation, secure L2 VSNs provide for connectivity to data center services. The whole end-to-end design yields a closed network system environment that is totally isolated from the outside world. There is simply no way in or out. Better yet, there's really no way to discover it. As mentioned, areas where stealth network topologies are useful are in networks that require full privacy, such as PCI or HIPAA compliance. Layer 3 virtual service networks are perfect for these types of applications or solution requirements. This slide could easily be an illustration for a PCI-compliant environment, in which all subsystems are within a totally closed L3 VSN IPVPN. The only ingress and egress are through well-defined virtual security perimeters that allow for the full monitoring of all allowed traffic. This combination yields an environment that, when properly designed, will easily pass compliance and scanning analysis. In addition, these resilient networks are not only private, they are invisible to the external would-be attackers. The attack surface is mitigated to the virtual security perimeter only. As such, it is practically non-existent. While it is clear that Fabric Connect can provide the degree of secure segmentation required for instances of compliance, this only will work if we can control who can access what and with which device. With Avaya's Fabric Connect, there is an integrated intelligence into the network to provide for this identity management requirement, which is of critical importance to any risk reduction plans. Additionally, such a service should be focused on minimizing the operational impact of adds, moves, and changes of devices, users, or policies. And finally, it needs to be open and able to operate with any device, network technology, or even vendor. Avaya's Identity Engines provides for the authenticated access to the fabric, but is much more than just a typical network access control point. It is a complete identity management system that provides for a very open directory abstraction layer that allows for the system to integrate with a number of directory services. This makes Identity Engines a great way to provide an integrated policy enforcement environment with disparate directory services and repositories on the back end. It also provides for a network abstraction layer, which allows for the open leveraging of various networking technologies from practically any vendor. As such, it is a perfect identity management system for mixed vendor environments. Avaya has taken things a step further by making Identity Engines a key architectural foundation block of SDN Fx. When combined with Fabric Connect, some very powerful capabilities become a reality. In an early blog article, I introduced the concept of composite identities and the fact that all identities in cyberspace are as such. This basic concept is rather obvious when it speaks to elemental constructs such as device-user combination, but it gets smeared and somewhat fuzzy when the concept extends to applications or services. Or it can extend further to elements such as location or systems that a user is logged into. All these elements are a composite instance of a user, and they are contained within a space-time context. As an example, I may allow user A for access to application A from location A with device A, but any other location, device, or even time combination may provide for a totally different authentication and consequent access approach, or perhaps the complete denial of service. This composite approach is very powerful, particularly when combined with the rather strong path control capabilities of Avaya's Fabric Connect. This combination yields an ability to determine network placement based on user behavior patterns and ID, those expected and within profile, but more importantly, those that are out of the normal user's profile. These instances may require additional access challenges and consequent authentications. As noted in the slide, the series of gates concepts merges well with this construct. The first gate provides identification of a particular user-device combination. From this elemental composite, network access is provided according to policy. From there, the user is limited to the particular paths that provide access to a normal profile. As the user goes to invoke a certain secure application or log in as a different user to use that application, the network responds with an additional challenge. This may be an additional password or perhaps a certain secure token or biometric signature to reassure the identity for an added degree of trust. All of this is normal. But in the normal environment, the access is provided at the system's level, thereby increasing the smear of the user's identity. A critical difference in the approach we are referring to is that the whole network placement profile of the user changes. In other words, in the previous network profile, the system that provides the secure application is not even available via any available network path. It is by the renewal of the challenge and additional tiers of authentication that such connectivity is granted. Note how I do not say access, but connectivity. It's a big difference. Certainly, system access control would remain, but by and large, they would be the last and final gate. At the user edge, whole logical topology changes occur that place the user into a stealth IPVPN environment where secure access to the application in question can then be obtained. Look at what happens when Avaya's SDN Fx is deployed. It effectively creates an intelligent fabric for secure virtual networks. You get faster time to service, lower latency, and an overall reduction in the provisioning of errors because everything is configured on the edge of the network. In the case of a guest access example, a totally automated portal can be provided via an untrusted zone that will allow for the guest to register into the system. The system will respond via email or SMS with the guest password for access. Alternatively, this can be handled manually by an administration assistant who can issue the password to the visitor as they sign in. The network connectivity for the guest will be provided internet access with no direct touch points to any internal resources. There, they can run whatever VPN clients they require for home network connectivity. The baseline is secure guest BYOD services with minimal risk and overhead for IT. In the case of a corporate desktop example, the same type of untrusted zone is used. No one is trusted at the outset, regardless of who they are. This creates a zero-trust network perimeter that only allows access once an entity has been classified and authenticated. Once the device and user is classified and authenticated via identity engines, it is then provided access to the corporate network as required or to any secure stealth service as required. In some instances, there are no users. This will be increasingly the case with the evolution of the Internet of Things to the Internet of Everything. Here, SDN Fx adds another dimension of flexibility and security by the introduction of intelligent attachment via fabric attach, which has been proposed and standardized in IEEE 802.1 QCJ, referred to as auto attach. Fabric attach provides for a stronger method of MAC authentication for devices that do not support full 802.1x. In this example, we have an IP video surveillance camera that boots into the network in an untrusted zone. In instances where 802.1x is supported, the camera can be placed according to policy. In instances where fabric attach is supported, MAC authentication can be used with a high grade of security against MAC spoofing attempts. In this instance, the video surveillance camera is classified and authenticated and placed securely into the proper stealth service without the risk of traditional MAC authentication alone. Additionally, fabric attach and the standard provides for an optimization of the service edge. This is a key development in the support for next-generation mobility requirements. It needs to be realized, however, that while Fabric Connect provides for invisible services, it does not provide for encryption of the overall traffic. The traditional higher layer methods such as SSL and IPsec most certainly work over the fabric, so if you have these types of services, they can be easily moved into the fabric as an integrated security function via identity engines. Additionally, we have recently introduced integrated security at the Ethernet trunk level by the use of MACSec. MACSec works at the link level between two switching elements. When combined with the true stealth capabilities of SDN Fx, it provides for a very dark, encrypted service with little, if any, exposure of attack surface. MACSec provides for a very high level of business-grade security. In the MACSec paradigm, the security triad is satisfied by providing data confidentiality, meaning that the contents of the message remain secure. Integrity, which is to assure that the content is from who it is from, and has not been modified by a middleman type process. And finally, authentication, which assures that the communication is between two nodes that have established a secure authenticated MACSec bonding. MACSec is an integrated feature within the newer Avaya Fabric Connect switching portfolio products. SENETAS is a Layer 2 encryption manufacturer based in Melbourne, Australia, and they have specialized in this area of technology since 1997. We have a very well-established technology partnership with SENETAS. They have a range of products which are highly regarded worldwide. Thanks to recent research and communications between Avaya and SENETAS, there has been the recognition that there are significant benefits for both companies in presenting the Layer 2 encryption solution for SPB networks, specifically for Fabric Connect. Many of the messages you've heard earlier in the presentation can be applied to this encryption technology. Important, the same statements made about a Fabric Connect network after installing the encryption technology remain valid. Looking to the slide, it should be highlighted on 3 points from the bullet headings. First of all, certification. Every device has passed at least FIPS 142 and Level 3 and Common Criteria EAL2+. This reflects our desire to have our technology independently verified. Low latency, less than 10 microseconds per user device at 1 gigabit per second. This is a pretty much inconsequential delay to the end-to-end flows. Lastly, support for all Layer 2 network topologies. This is a significant benefit because multi-point networks are problematic for many other technology approaches to encryption. This all goes against the general supposition that encryption is complicated and disruptive and costly. SENETAS and Avaya's Fabric Connect, with the above feature set, is committed to disproving these assumptions. Aside from technology, it is important to establish proper security practices. And with security, consistency is a very good friend. Consistency is implemented and maintained by the use of templates. These templates reflect standard technical implementation guidelines, or STIGs. The use of templates allows for consistency and makes it easier to maintain compliance over time. Templates can be anything from network hardware to applications and operating systems. Examples are switch models and types, network topologies, both physical and logical, as well as security demarcation and server storage infrastructure. But as pointed out, also consider templates for supported applications and operating systems that are to be allowed into the constrained stealth domain. This slide shows a higher level view of the template concept. By dictating module demarcation points and implementing the modules exactly as defined within the templates, compliancy can be streamlined. As an example, for a remote point of sale location, if a series of templates were created, such as small, medium, and large, and those templates covered all hardware, network topologies, and configurations, and those templates were also adhered to strictly, then at the time of compliance scanning, only one of each site really needs to be actually visited. Network topology documentation and configurations can be used as dual equivalents for all other sites of that type class. If an organization is dealing with a large number of point-of-sale locations, this approach can have significant impact on the overall cost and difficulty of attaining and maintaining compliance over time. Partner companies such as VMware and Palo Alto complete the complement of the ecosystem, as well as strong benefits from the use of stealth networking within the data center and at the security demarcations. Avaya's Fabric Connect provides for a unique and powerful VPN technology. The Fabric service extension capability and its dynamic characteristics create what we refer to as services elasticity. But there is another, even more powerful aspect of the Fabric, and it has to do with the nodal intelligence of its switches. These nodes can move about the network topology. A Fabric Connect node could be disconnected, moved, and reconnected in a totally different location, even after long periods of shelf storage. Once the node is deployed, it will dynamically authenticate and reconnect with the Fabric. All network services will be established, and no one touches a keyboard. We refer to this as nodal elasticity. Such a powerful characteristic makes Fabric Connect a very attractive technology for field deployment type situations, particularly when it is married with certain wireless technologies such as point-to-point microwave or the more recent TVBD spectrum reuse initiative. Additionally, coherent optical beam technologies allow for line-of-sight communications up to 40 kilometers. This slide shows an example of nodal elasticity in action. The automatic reestablishment of network service and connectivity in such a dynamic fashion makes it ideal for oil and gas operations, emergency response, military, even news and entertainment. In short, any instance where quick, reliable, but highly secure high-bandwidth communications is required. As can be seen, while Avaya is not really a security company in its definition and charter, it still plays a significant role in the overall layered defense model and the cybersecurity framework. Engagement solutions and real-time communications are simply applications running on the network, which means that security has to be addressed holistically rather than application by application. Avaya solutions are designed to work together in a holistic manner to provide both defense in depth as well as defense in breadth, regardless of the location of the user in relation to the security perimeter. The key elements that must be addressed in all solution frameworks are access control. Who is allowed to be on the network? Security policy enforcement. What are users permitted to do on the network? And what has to happen before they can enter? For example, in order to register, a device must be using TLS, SRTP, and have the appropriate authentication certificates. Privacy. This means signaling, media, and data, and the network infrastructure should be hidden, masked, or encrypted, depending on the level of risk. And threat protection must be applied to all traffic, including real-time communications. The engagement platforms have security built into each solution, which introduces layers of security across the entire portfolio. Clients have VPN-less or application-specific VPN security inherent to the application to increase adoption rate. They also have mutual authentication capabilities. Session Border Controller sits within the DMZ, working hand-in-hand with the public-private firewalls, and can also sit in the core, creating an internal barrier to protect from inside threats. Session Manager, Communication Manager, and Contact Center all have security mechanisms built in, including certificates, password aging, complexity, as well as lockout policies, and others. SDN Fabric Connect, again, is inherently secure and simple to implement and manage. Remember, complexity breeds vulnerabilities. Avaya's solution, when utilized together and in tandem with our partners, create not only a layered defense in depth, but also, and perhaps more importantly, defense in breadth. There are multiple control mechanisms at each layer providing security in a holistic fashion. They are powerful individually, but when used together create a strong defense to enhance one's cybersecurity framework with Avaya's stealth network services at the base network infrastructure. From Avaya's Fabric Connect perspective, it's all about service separation and path control, or network segmentation, as it's referred to in security compliance documentation. No other networking technology can provide a more comprehensive set of services with so little complexity. As a result, the checklist is fairly easy. Be sure to terminate L3 VSNs as close to the edge as possible. Avoid using shared broadcast domains or VLAN extensions via shared trunks off the IPVPN environment. If VLAN extensions off of the VRF are required, use stealth L2 VSNs to maintain total separation and obscurity. Limit port membership to the security demarcation and only to those required. Ideally, this should be a single port membership to prevent unauthorized access to the DMZ. Limit port memberships only to the secure authenticated endpoints. Identity engines can greatly ease the enforcement of these access policies. And avoid mixing any non-secure applications in the secure stealth networking topology, even if they don't access anything outside of the network service, as such mixing can result in the violation of compliance templates, particularly PCI DSS, and hence, in turn, require full scanning. Validate the security demarcation module and create a defined security policy database that's standardized and in coordination with the network topology template. Be sure to do testing on the demarcation to be sure that the policy database is enforced. Finally, avoid the use of public internet or wireless services within the end-to-end design. When this cannot be avoided, use encryption to protect transit data. MACSec or SENETAS encryption can be used to protect exposed Ethernet trunks, and full VPN encryption can be used with IPsec or SSL to provide endpoint or even branch site security. As a note, be sure to have the VPN gateway attached directly to the stealth topology to ensure that there are no exposed, unencrypted data service paths. While private IPVPN environments have been around for years, they are typically clumsy and difficult to provision. This is particularly true for environments where quick dynamic changes are required. As an example, the typical MPLS IPVPN provisioning instances can require up to 200 command lines depending on the vendor and the topology. Interestingly, much of this CLI activity is not in provisioning MPLS itself, but in provisioning other supporting protocols, such as IGP and BGP. Also consider that all of this is just for the initial service path. Any redundant service paths must then be manually configured. Compare with Avaya's Fabric Connect, which can provide the same service type with as little as a dozen command lines. Additionally, there is no requirement to engineer and provision redundant service paths, as they are already provided by Fabric Connect's intelligent integration of network topology and residence services in respect to it. As a result, IPVPNs can be provisioned in minutes and be very dynamically moved or extended according to requirements. Furthermore, Fabric Connect nodes themselves are movable and mutable. Once again, ISIS provides for this feature. A Fabric node can unplug from the network and move to the opposite end of the topology, which could be hundreds or even thousands of kilometers away. There, they can plug back in, and ISIS will communicate the nodal topology information as well as provision services on the node. The Fabric will in turn extend those services out to the node, thereby giving complete portability to that node as well as its residential services. In addition, Fabric Connect can also provide for separation of non-IP data environments as well. Protocols such as SCADA and other IEC-type protocols can enjoy an isolated non-IP environment by the use of stealth L2DSNs. And further, they can be isolated so that there is simply no viable path into the environment for would-be attackers. This combination of privacy, fast mutability of both services and topology lend to what are termed as stealth networking services. They are dark, so they cannot be seen or attacked due to the lack of service for such an endeavor. They are swift in the way they can morph service extensions, and they are extremely mobile, providing for the ability for nodes to make whole-scale changes to the topology and still be able to connect to the relevant provision services without any need to reconfigure systems. Any other IPVPN technology would be very hard-pressed to make such claims, if indeed they can make them at all. Avaya's Fabric Connect, based on IEEE 802.1 AQ, sets the foundation for the true private cloud. With it, compliance becomes much, much easier. Thanks for your time. We hope that you found this session both informative and helpful. For more details on Avaya's Fabric Connect stealth networking technology, feel free to contact your local Avaya representative or partner. In addition, my email address is provided on the slide. Feel free to reach out with any questions.